Okay, so most of you know I've been working on this robot for a while, and well, it's grown quite a bit. So, to begin with, I started out by making the pieces out of just simple little pieces of plywood. So I had these, little legs with pivot points, and I quickly realized that the wood was not going to work. I tried to coat it in epoxy resin with blue mica dust, and I could not get it to coat evenly to save my life. So, out went that idea. Next came Resin. I decided I would try using 1/8 inch thick Resin that would basically be riveted together using just simple pop rivets for the pivots. And well, here's what they started looking like, minus the servos, because I removed the servos. I was using these little dinky servos here that you see. They're only 9G servos, and well, with the weight of the bot itself, it was unable to even process the leg. The leg would twitch like a dying fly. So, decided to go with a larger servo. In came these guys. You see here, these guys are rated for upwards of, I believe it was 9 kilograms of pushing power. Could be 12, but I think it was 9. At any rate, so now I had to figure out what to use to make the body parts with. Well, I don't have a 3D printer, and I don't know anybody personally that would let me use their 3D printer. So I went with epoxy resin. The stuff's, when it's done right, it's rock solid. You can use any mold you want as long as it retains the resin. I just learned this lesson the hard way. First off, this here you see is a mock-up of the leg. There will be linkage made from these parts here that will connect the servos to the servo horns to cause the leg to expand and contract. Now there will be 6 of these legs in all. So you can see by the size of this next to my hand, this is no small robot. This thing, when done, is going to be about the size of a small dog. So I cast a bunch of these parts. These are the, you see these taped marks here. These are actually skateboard bearings, which are these pivot points here I use with just a large screw and a nut. These here, this is how it connects to the actual robot. Now you can see here that these are where the servos go. This is the main chassis part. Now, I cast this using cardboard with a wax-coated layer. What I did not know was that there must have been microscopic pinholes in the wax layer, because after the resin cured, I don't know if you can get a good view of that, you can see the cardboard actually became a part of the resin. So as I was trimming it down and taking the mold off, I realized part of the mold is now part of the resin. There is no way to get this off. It is actually ingrained in the resin. So this entire piece is unusable. That cardboard creates a failure point. Now there's going to be 3 servos per leg, 6 legs in all. That's 18 servos. Plus a servo here to connect to the second part of the chassis. This is the articulation point so the robot can turn. Cannot use that because all the torsional stress from all these servos will actually snap this piece. So I've had to recast a new chassis. It's actually curing right now. Unfortunately, I couldn't get the blue in it to go right. I've been having a little problem with that. But this here, these pieces are the front. So this will connect. Now, assuming, chassis part, this part will connect here onto a servo. This is the drop down from this piece. I obviously have to trim it. And then this part will sit here with two more servos. This is where the front legs will be. There'll be a head here, but that's, phase 2. Phase 1 is just getting the robot to walk. I'm doing this video now to illustrate, what you can do with epoxy resin and how to have it go wrong. You can see these are kind of light colored. I've been sanding them, with a 600 grit sandpaper to start with, just to smooth out the top. I discovered, while some of these pieces are rock hard, some of these pieces are not. You can see they flex. Some more than others. That leg will do me no good. That's my fault. This has actually been resting for probably 3 or 4 days. So it's had more than enough time to cure. So 7 pieces in all of the leg system are unusable. They've had more than enough time to cure. I've tried to temper them. It won't work. So I have to recast all those pieces. But, live and let learn, or whatever the saying goes. The bottom line is I screwed up. I didn't mix the epoxy good enough. The hardener didn't bind with the resin and cause it to solidify properly. So, as I said, that's 7 parts. Now, this piece here, I'm going to be cutting in half, shaping, trimming it down. And what it's going to be is there's going to be 2 pieces that connect here. There'll be stanchions on top. They won't be this tall, obviously. I'm going to trim this down. But they're going to stand on either side here with helper springs to bear the weight of the front, so the servo doesn't have to do all the work. These servos are extremely strong. I've run them, tested them. One servo alone can easily move all these things. So to have 18 of them just on the legs alone, you can imagine the torsional stress that'll be put on this chassis. So, hopefully the new section cures perfectly and I'll be able to trim it down and get it going. Unfortunately, I've run out of resin. So you can see how many parts are involved here. This isn't even all of them. I have other parts that are still curing. So you can imagine going from, this here to this to now this. It's coming along. Hopefully I will get it assembled soon. I've made some spare pieces, such as this. I haven't decided what color I'm going to go with. I've got a gold, a purple, and a dark teal that I was going to use for the linkage that connects the servos to the servo horns, which gives the leg its motion. Obviously, and you could see an example of those I made with, the leg stand. That's what these pieces here are for, only upscaled to bear the strength and the weight of all that. So, it is what it is. I'd like to thank Flathead Corruption Watch, Chris P., Jamie Smith, and Flower Girl Deb for helping me be able to do this with getting parts and getting resin and getting it going. You know, it's been a journey so far, and this is just the first video that you guys are going to see of this. The next video, part 2, hopefully we'll be at a stage where we will have a walking robot. I'm using an Arduino Mega microprocessor board with a PCB I soldered up myself. And what I did was I created pin sets for each leg, so 6 pin sets in all. Each pin set, I give it a 470 UF capacitor to help power the legs. And I'm going to be using this here. This is a 10,000 milliamp hour USB battery backup. So it puts out between 5 and 6 volts, which these servos are rated at 6 volts, and the Arduino board runs on 5 volts. So this here will be enough to power all the legs and the microprocessors. As time progresses, I'm going to be adding a head unit with infrared and sonic sensors for object avoidance. And so, like, if I walk down the sidewalk, it will follow me. It will always make sure it stays a certain distance right behind me. So, you can imagine there's a lot involved in all this. I'm writing all the software myself using the Arduino built-in C++. But it's coming along. So again, thank you to those that helped contribute to this. And, thank you for all my viewers for watching and, cheering me on as I go.